Hi Ken, last time you asked me to learn about power capacity and electric energy consumption. Today I need your help to understand more about it.
Before I answer, I want to know how do you understand it?
Power equals voltage multiplying amp rate, the unit is watt or kilowatt. Light bulb 12 voltage and 6 watts, fan 220 AC voltage and 60 watts. 1 kilowatts equals 1000 watts. Electric energy consumption is kilowatt hour. If you use the fan for 10 hours, it costs 600 watt hour, equals 0.6 kilowatt hour. But power capacity of battery is shown in a different way, 12 voltage, 50 amp hour. Why such a difference, what do you think?
Electrical equipment show watts, to let you predict energy consumption, which you will need to pay for using them. The battery is used for the remote, we paid for it, so what we care about is the duration of use. Example, 1.5 voltage, 1500 mAh battery, is the capacity. If we use with load 1500 mAh, it will run out in about 1 hour. If you use it for load 1.5 mAh, you will use it for 1000 hour. Similarly, the battery of a phone is rechargeable. We are often more interested in how long it lasts than how many watts it takes to charge. But the time is only an estimate for comparison between batteries. Actual usage time depends on how we use the phone. If you use your phone to play games, the battery will run out faster than just reading the newspaper. In other cases, the battery used for car will be recharged by the car's engine.
Why is this battery capacity so large, if this battery is automatically recharged by engine?
Good question, what do you think?
I think it will store power, in case the car is not used for many days.
Battery power is generated by a chemical reaction inside. I will describe it in a way that is easy for you to remember. I describe it as liquid gas in a container. When you use gas to burn, the liquid will change to a gas, to compensate for the lost pressure. This energy conversion process takes time, because it cannot be taken too much at once. For a car, starting it requires a large amount of energy and immediately, the engine will take a few seconds to activate. So we need the large capacity battery, to be able to supply ampere current to start.
What happens if I try to start with a lower capacity battery to start the car?
If the battery capacity is too small, the engine cannot be started. You can use it in case of emergency. If the capacity is a little less, then the battery will get hot, and it will be damaged quicker. Liquid gas, if you use it over capacity, it will be cold, and even freeze, very dangerous.
In addition to showing in watt or kilowatt, I also see power capacity in kVA. What does it mean?
For AC power, the power is multiplying with the cosφ, power factor. DC, cosφ equals 1, so we don't care. Apparent power is the vector sum between real power and reactive power. For resistive loads, voltage and current are same phase, means no delay. If the source has a power capacity of 10 kVA, the load will consume 10 kilowatts. For one coil, if there is current flowing through the coil, there will be delay and create one reactive voltage. So voltage and current phase difference, phase delayed. Assuming cosφ equals 0.8, if you have the source of 10 kVA, you only use 8 kilowatts.
Where's that energy? We lost it, right? 2 kilowatts.
We don't lose 2 kilowatts, just use inefficient power capacity, and loss on transmission line.
Hey Ken, you know I won't be able to learn this boring stuff. Is there an easier way to have fun?
I have a factory with a capacity of 10 kVA, there are 10 trucks, each 1 kVA. Resistive loads need 8 kilowatts, so I send 8 trucks there. I have 10 trucks, so I can send more for resistor load 2 kilowatts. As a result, I used 10 trucks, and sold 10 kilowatts for resistor loads. For induction load, it's like a difficult zigzag road. And a difficult customer. Because the road is difficult to move, if he buys 8 kilowatts, he needs to say 10 trucks come here. In one very short power cycle, 10 trucks but have to wait for delivery. And consume only 8 kilowatts for 8 trucks. So you can see it is not efficient in transmission, causing waste. We don't lose 2 trucks, but we do cost to move 10 trucks and wait. If one more 2 kilowatts load, need 2.5 more trucks. So the current capacity is not enough, we need to upgrade.
I can understand that, we are wasting in transmission, because induction load delay. So how to solve this problem?
We won't work with this difficult customer anymore. We build a warehouse, and ship to there. During in transmission, we don't have to wait.
That's good, then we should build more storages.
Attention, the warehouse must also not be larger than the needs of the load, otherwise it also wasteful. Similar to building a warehouse, in reality the factory they add capacitors. Target is cosφ near 1. Because less or greater than 1 is not good. They use the device to read, and automatically balance the cosφ, like this.
In summary, power capacity is a representation of voltage and amps. Same voltage, if the power capacity is larger, mean able to supply amps will be greater. In another case, the capacity is also larger if the voltage is larger. Attention, when using the electric device, you must use the correct voltage of the device. Okay, I figured out the power capacity, and learned many things, thanks a lot.
Never mind, see you later.
Remember to click like, and share to help those in need like me. Thank you for watching.